We're going to dive into solving equations, and this first sheet it just gives you some overview of some steps and some things to remember. Solving equations is not anything new. Remember, solve means to find a value that makes a statement true. There are some steps here. So we think about when we look at an equation, we're going to distribute first any terms we see, combine like terms on either side of the equation, then we move them across the equal signs by doing the opposite operation. So for example, if we have addition or subtraction, we would do the opposite. If it was addition, we would do subtraction to get it to move to the other side and so forth. This is kind of reverse of order of operations. So you start with addition and subtraction, then multiplication and division before you move things. You always want to check your solution, and it should always make the equation true. If it doesn't, then you've done something wrong. With fractions being in there, they make us do really weird things, and so the best thing to do is clear the fraction, and that really means you're just multiplying each term by a common denominator. Hopefully the lowest common denominator, so you're not having very big numbers, and we'll do some of those clearing fractions and showing you what those mean. You can get one solution, which would make it true, or you can get no solution, which we represent with a 0 with a line through it. This means there isn't a number that will make the equation true. So for example, 5x plus 3 equals 5x minus 7. When we simplify that down, we get 2 equals 12. Well, we know that's not true, so that's not a solution. You could have infinitely many solutions, which you can also show with an infinity sign. That means like all real numbers. It means any number will make the equation true. For example, 2x plus 3x minus 1 equals 5x minus 1. When we simplify that down, we could get 2x equals 2x, or if we got rid of the x's, we could get 8 equals 8. Well, that's true. 8 does equal 8, and 2x does equal 2x, so that's infinitely many solutions. So when they look identical on both sides, that's identity property, and that tells you that they are all solutions. All right, so let's go into some examples. So we're going to start with some pretty basics. So solving equations, example A, we have first, we want to look at distributing. So we're going to distribute first. So think about this as a mailman. He's got to go to each house that's inside the parentheses. So we're going to think about 4 times 2a and 4 times a negative 1. So 4 times 2a gives me 8a, and then 4 times a negative 1 gives me a negative 4. Think about this as being a wall here. We want to do each thing on each side of the wall. So we're simplifying down. I can't combine any like terms. 8a can't combine with 4, so that's as simple as I can go. Now let's do the other side. Negative 10 times a is negative 10a. A negative times a negative gives me a positive 50. And I can't simplify anything there. So there's no like terms to combine on each side, but now I want to move things together. So I want to get my a's on one side together, and I want to get my numbers on one side together, just my constants. I like to look and see, it doesn't matter which side you move where, but I like to look and see where I can have positive. So if I know this negative 10a can go over here with 8a, to do that I have to do the opposite. Right now I'm subtracting 10a. I'm going to add 10a on both sides. Negative 10a and a positive 10a is now gone. They've canceled each other out, and now I have just this 50 left, so I'll bring it down. 8 and a 10a gives me 18a, and then I bring down my negative 4. And now I'm getting closer to getting that a alone, so now I want to move over my numbers, and I could have moved the numbers first. This is minus 4, subtracting 4, so I want to add 4 to each side. Now cancel this out. I have 18a equals 54. And now I'm done with moving stuff by adding, subtracting. I'm going to now solve by the inverse operation of what's happening. So this is 18 times a, so we know it's multiplying. To undo multiplication, we divide. Divide by 18, divide by 18. Always divide by your coefficient. So this is gone, and now we have a 1, so we just have a 1a. And 54 divided by 18 is 3. So this is a one solution. This is an example of one solution. Now we want to check ourselves and make sure we're correct. So we're going to plug in our 3 and substitute it back into the beginning. So 4 times 2 times 3 minus 1 should equal negative 10, 3 minus 5. And now let's check to see if it's the same. So 2 times 3 is 6. 6 minus 1 is 5. 5 times 4 is 20. Negative 10, on the outside we have 3 minus 5, so that's a negative 2. A negative 2 times negative 10 is 20. So it is correct. So we know A is 3 in the situation. All right, let's look at B. So I want you to pause the video here and see what you get for the next two, B and C, and then we'll come back and see what you've gotten. All right, so we look here, 2n plus 2 plus 12, and 17 plus 2n, down our wall. We're going to move. So we see 17 equals 14. That is not true. That is a no solution. All right, the next one that you worked, C. Both sides. Can't do anything on this side. When we get to here, we should see that they're identical. This is identical here. And we know if we move things over, we could say plus 2, plus 2. These would be gone. We would get 3a equals 3a. Or if we got rid of the 3's first, we could see that this is all real solutions. This is all real solutions. So this is that identity property. All right, now let's go into clearing fractions. So I did a little squiggly that tells you a new train of thought is happening. We're going to start pretty basic, and I'm going to show you how you normally would do it and how then with clearing fractions, how it makes it much easier. So A and A subprime 1 here are the exact same questions, and I'm going to show you how you normally do it. So normally to be able to add fractions together, you have to have common denominators. So we would get 3 and 4. We'd say, okay, common denominator is 12, and we're going to change both of those to 12. 3 can go into 12 4 times. 4 times 1 is 4x. Then 4 can go into 12 3 times. 3 times 1 is 3x, and then equals 4. Then we would add. So we'd have 4 and 3, and we would get 7/12 x equals 4. Now we're going to get rid of this side and get x alone, and this is multiplying. So to undo, we were basically showing that we would divide by 7/12, or the same thing as multiplying by the reciprocal on both sides. So this cancels out, and we're left with just x. Here, we can't reduce any. This is 48/7. And then you want to check. So let's talk about what that would look like if we clear the fraction. So if I clear the fraction, what I'm trying to do is find the lowest common denominator that I can multiply all the pieces by, and it has to be to all the pieces. And we'll talk about what distributing looks like in a minute. So if I look at 3 and 4, I can think, what's my lowest common denominator? Lowest number they both can go into. Well, the lowest one is 12. So I'm going to multiply the whole thing, and I like to put a big bracket, times 12. What I'm doing is I'm multiplying each individual piece. I go 3 can go into 12. How many times? 4. 4 times 1 is 4. So I get 4x. 4 can go into 12 3 times. 3 times 1 is 3. I get 3x. And then 4 times 12 is 48. Now I've gotten rid of the fractions. It's a very simple problem. Now it's just 7x equals 48, and then divide by my coefficient of 7, and x equals 48/7. Same exact answer as I had the first time, just a lot less fractions involved. And this will really be helpful when you have all kinds of really crazy stuff. So let's go to another example, B. So here I'm going to look, and I'm looking at my denominators. I have 3, I have 4, and I have 12. I want a number that all of them can go into equally. The lowest one, preferably. I don't want a really big number. So I know that 12 can go into 12, and 4 can go into 12, and 3 can go into 12. So I'm going to use 12. So we're going to put a bracket, multiply the whole thing by 12, and then this is what we're doing. 3 can go into 12 4 times. 4 times 2 gives me 8. 4 can go into 12 3 times. 3 times 3 gives me 9, and don't forget your x. 12 can go into 12 one time. 1 times 71 is 71. Now I have a very simple problem. I want to get an x alone, so I'm going to go ahead and move this 8 over. It's adding right now, so subtract 8, subtract 8. Put my wall there. I have 9x. These have now canceled out. And then 71 minus 8 gives me 63. divide by my coefficient of 9 on both sides, so I get x equals 7. If I plug that back in, and you can use your calculator to check, I would see that I'm correct. All right, let's look at C. C is another simple one, so we're going to look and see. So I'm looking at all my denominators. I have 3, 6, and 5. I want to find a common denominator, and if for some reason you pick one that's too big, it'll be okay. You'll just have to simplify further. So if this one over here throws you off, you have to touch every piece. You can think about that being a 1 there. It's no different. It's still a 1. So if we have 5, 6, and 3, my lowest common number would be 30. So I'm going to put brackets and 30. Well, 3 goes into 30 10 times. 10 times 2, because this is all I'm doing, I'm saying 30 times 2/3. You can think about it this way, but I'm cross-reducing. I'm saying this can be cross-reduced into this, and then multiply straight across. That's exactly what I'm doing. So 3 and 30 goes 10. 10 times 2 is 20x. Now, 1 can go into 30 times. 30 times 1 is 30. Or if you didn't have that 1 there, because you didn't put it there, it's just multiplying it, 30 times 1. Then we have 6 goes into 30. 5 times 5 is 25x. And then 5 goes into 30 6 times a negative 2 gives us a negative 12. So now I have a very simple problem. See, I'll put my wall there. I'm going to move things left to right. So if I do minus 20x, I end up with 5x. 30's on this side. Bring down my 12. Then plus 12, I have 42 equals 5x. Divide by my coefficient, and I have x equals 42/5. So you want to keep these as improper. When you're working on your practice, always keep them as improper if they are. You don't have to change them. There's no reason to. All right, let's go to D, and then we'll get into a little bit harder ones. So D, we have 3, 5, 15. We don't even need to think about this one. You can put a 1 under there if it helps you. And we're going to find a common denominator they'll go into. So if I look at 3, 5, and 15, a number that all of them can go into is 15. So I'm going to put my brackets. 3 can go into 15 5 times. 5 times 1 is 5, so I have 5x. 5 can go into 15 3 times. 3 times 2 is 6. My wall there. 15 can go into 15 1 time. 1 times 1 is 1, so I have 1x. And then 1 can go into 15 15 times. 15 times 2 is 30. Now I want to move things left to right. So I'm going to start with my numbers this time. Minus 6. I have 5x on this side. And then I have a 1x and a plus 24. Now I want to move this x over, minus 1x. I end up with 4x equals 24. Divide by my coefficient, and I have x equals 6. And you will check. Now, when I put little stars, that means that they're a little bit more challenging. So when we look at these, they're going to get progressively more challenging. So notice here that I have x minus 1 on top. So I'm still going to use the same concept as finding the lowest common number that they both can go into. So I look at 5 and 3. 15 is one they can both go into. So 5 can go into 15 3 times. 3 times 2x is 6x. 3 can go into 15 5 times. I have to multiply all of this. So you can think about it looking like this. 3 into 15 goes 5. This is what we're doing. We're doing 5 times x minus 1. And sometimes it's best to do this step and trying to do it in your head. And then we can think about this as a 1 underneath there, or we can just think about 15 times 4 equals 60. Now, because we left that as distributing, we want to go ahead and distribute. So I have 6x plus 5x minus 5 equals 60. Combine like terms before we move. So 6x and 5x are like terms, so we have 11x minus 5 on this side. Simplified down that side equals 60. Plus 5 to get the 11x alone. And now we have 11x equals 65. Divide by our coefficient. We have x equals 65 11ths. And you always want to make sure this is simplified down, but you can keep it improper. But there's nothing else that can go down to. All right, let's try another. So we got 4 and 3, and notice this is the same kind of situation where we have something that we have a whole piece up here. They're not always going to put parentheses around it for you, so make sure you're careful with that. So if you look and see what you can do. So pause the video and then come back and see if you got it right. All right, there's the answer to F. Now we're going to move up to a 4-star. So G and H are going to be a 4-star and a 5-star. So if you'll try it and then come back and I'll have it work for you. All right, so let's look at G. I picked 3, and when I did this, I just focused on the outside, what's on the outside part here to clear the fractions. I did not touch what's in this bubble here in the parentheses, because if I touch each piece now, that's going to make it much bigger than it needs to be. Meaning, if I multiply 3 2/3, and then I multiply 3 times 4x and 3 times 3, and then once I do it again, I have to distribute these, I'm going to get a very big number. So I'm changing more than I need to. So when you're clearing fractions with something in parentheses, you don't touch the bubbles. So you think about 3 goes into 3 one time, 1 times 2 is 2. And look at everything in the bubble stayed the same. Now I could have went ahead first and distributed first and then cleared the fractions. That's completely fine. But I can't touch inside the bubble the first time with clearing the fractions if I haven't already distributed. So when I worked it through, I went to get at the bottom 4x equals 0. Many times people will confuse when they see this right here with a no solution. But remember, we got another step. So we divide by 4 on both sides. And if we take 0 divided by any number, it's still 0. So our answer is x equals 0. And then if you plug it back in, you'll see that's correct. Now for H, it was a lot more complex. So we can start with first, if we're going to clear our fraction, we're going to start with just looking at our fractions here. We have 3 and we have 9. We're finding something they both can go in. That's where I picked my 9. So then 3 goes into 9 3 times. 3 times 2 got me this 6. Everything else in the bubble stayed exactly the same. Same with over here. 9 can goes into 9 one time. 1 times 1 is 1, and the bubble stayed exactly the same. Now, I'm going to go ahead and distribute this next section, and I end up with 6 times 1/4 is 6/4 x plus 18, and then distribute my bubble here, 1/2 x plus 1/4. Now I have more fractions. Now I can clear those fractions again. Now, if I originally started and I went ahead and distributed first, then I would only have to clear once. The problem is sometimes working with fractions to begin with, we make mistakes because fractions seem to be one of those things that get us. So we can clear the outside fractions, then distribute, then clear the fractions again. So when I picked the new one, I picked 4 because I looked at 4, 2, and 4, and then I distributed from there. So 4 goes into 4, or cleared from there. 4 goes into 4 once. 1 times 6 is 6x. 18 times 4 gives me 72. 2 goes into 4 twice. 2 times 1 is 2, and don't forget the x. And then 4 goes into 4 1 times 1 is 1. Then I combined terms by moving things left to right on the side of the equation, and I end up with the answer of x equals negative 71/4. So remember to always keep these as improper fractions in the simplest form, which means if I have something like 10 18ths or 10, let's say, 8ths, that's improper. I'm going to simplify it down. 2 can go into both of those and make it simpler, so 2 can go into 10 5 times and 4 times. This would be my final answer. It's still improper. I'm not changing it to a mixed number, and I'm not changing it to a decimal. That's really important to know.